Hello and welcome back to our channel. In today's video, we'll be discussing the importance of machine learning and its relationship with Python in data science. Machine learning is an essential field of study that uses algorithms and statistical models to enable machines to learn and improve on their own without being explicitly programmed. It is a rapidly growing field that is revolutionizing the way we interact with technology, and it is a critical aspect of modern data science. Python, on the other hand, is a high-level programming language that is easy to learn and use, making it a popular choice for data scientists and machine learning practitioners. Python provides a powerful and flexible environment for data manipulation, visualization, and analysis. The importance of machine learning. Machine learning has numerous applications in various fields, including healthcare, finance, marketing, and manufacturing. In healthcare, machine learning algorithms can be used to detect diseases, predict patient outcomes, and develop personalized treatment plans. In finance, machine learning can be used to analyze financial data, detect fraud, and make investment decisions. In marketing, machine learning can be used to analyze customer behavior, develop targeted advertising campaigns, and improve customer retention. In manufacturing, machine learning can be used to optimize production processes, predict equipment failures, and improve quality control. Machine learning is also an important tool for data analysis and prediction. It enables data scientists to extract valuable insights from large datasets, identify patterns, and make accurate predictions. For example, machine learning algorithms can be used to predict customer churn, detect anomalies in network traffic, and classify images. In addition to the practical applications, the importance of machine learning can also be seen in its potential to drive innovation and improve efficiency in various industries. By automating processes and reducing the need for manual intervention, machine learning can help businesses save time and resources. It can also lead to the development of new products and services that were previously impossible or impractical to create. Another important aspect of machine learning is its ability to adapt and learn from new data. Machine learning algorithms can continually improve their performance over time by analyzing new data and adjusting their models accordingly. This can lead to more accurate predictions and better decision-making. However, it is important to note that machine learning is not a panacea and does have limitations. It requires high-quality data to produce accurate results, and its predictions are only as good as the data it is trained on. Additionally, the use of machine learning algorithms can raise ethical concerns, such as bias and privacy issues. Despite these limitations, the importance of machine learning in today's digital age cannot be overstated. It has the potential to revolutionize industries and create new opportunities for businesses and individuals alike. As more data becomes available and computing power increases, machine learning is poised to become an even more important tool for innovation and progress. The role of Python in data science. Python is an essential tool for data scientists and machine learning practitioners. It provides a wide range of libraries and frameworks for data manipulation, visualization, and analysis. Some of the most popular Python libraries for data science include NumPy, Pandas, Matplotlib, and Scikitlearn. NumPy is a library for scientific computing that provides support for large, multidimensional arrays and matrices. It is a fundamental tool for data manipulation and analysis in Python. NumPy, which stands for Numerical Python, is a Python library that provides support for large, multidimensional arrays and matrices, as well as a variety of mathematical functions to operate on these arrays. NumPy is designed to be both efficient and convenient to use, making it a fundamental tool for data manipulation and analysis in Python. One of the key features of NumPy is its ability to work with arrays of data. NumPy arrays are similar to Python lists, but they are more efficient for working with large datasets. Unlike Python lists, NumPy arrays have a fixed size and data type, which means they take up less memory and can be processed more quickly. NumPy arrays can be created from Python lists or other sequences, and can be sliced and indexed like regular Python lists. NumPy also provides a range of mathematical functions and operations that can be used on these arrays. These include simple operations like addition, subtraction, multiplication, and division, as well as more complex functions like trigonometric functions, logarithms, and exponentials. These functions are designed to work efficiently with large arrays, and can be used to perform complex mathematical operations on datasets quickly and easily. In addition to its support for arrays, NumPy also provides support for matrix operations. Matrices are similar to arrays, but they are specifically designed for mathematical operations like matrix multiplication, inversion, and transposition. NumPy provides a range of functions for working with matrices, including matrix addition, subtraction, and multiplication, as well as functions for calculating determinants and eigenvalues. NumPy is also an essential component of many other Python libraries for scientific computing and data analysis. Libraries like Pandas, SciPy, and Scikitlearn all rely on NumPy for their array and matrix operations. This means that learning NumPy is a key step in becoming proficient in scientific computing and data analysis with Python. Overall, NumPy is a powerful and flexible library that provides a range of tools for working with large, multidimensional arrays and matrices. Its efficient design and convenient syntax make it an essential tool for scientific computing and data analysis in Python. Pandas. Pandas is a library that provides data structures and functions for data manipulation and analysis. It is particularly useful for working with structured data and time series data. Pandas is a powerful open-source library for Python that is widely used for data manipulation and analysis tasks. The library provides high-performance data structures and functions to make it easier for data analysts, data scientists, and developers to work with structured data and time series data. Here are some of the key features of Pandas. Data structures. Pandas provides two primary data structures, namely series and data frame. A series is a one-dimensional labeled array that can hold any data type such as integers, floats, strings, etc. A data frame is a two-dimensional labeled data structure that consists of rows and columns. It is like a spreadsheet or a SQL table. Data manipulation. Pandas provides a wide range of functions to manipulate data, such as filtering, merging, grouping, sorting, and transforming data. For example, you can use the groupBy function to group data based on one or more columns and apply aggregation functions such as sum, mean, count, etc. Time series. Pandas has excellent support for time series data, making it easy to work with time-indexed data. You can resample time series data, shift data forward or backward in time, interpolate missing data, and perform other time-related operations. Missing data handling. Pandas provides functions to handle missing data, such as filling missing data with a default value or interpolating values based on neighboring data points. Visualization. Pandas has built-in visualization functions based on Matplotlib, a popular plotting library for Python. You can create various types of plots, including line plots, scatter plots, bar plots, and histograms. Pandas is a powerful library that provides data analysts and developers with a rich set of tools to work with structured data and time series data. Its easy-to-use data structures and functions make it a popular choice for data manipulation and analysis tasks. Matplotlib. Matplotlib is a library for data visualization that provides support for a wide range of plots, charts, and graphs. It enables data scientists to create informative and visually appealing visualizations that can help to communicate insights effectively. Scikit-Learn. Scikit-Learn is a machine learning library that provides support for various machine learning algorithms, including classification, regression, clustering, and dimensionality reduction. It also provides tools for data preprocessing, model selection, and model evaluation. Scikit-Learn is a powerful machine learning library that is widely used in academia, industry, and research. It is an open-source library that is built on top of Python and is designed to provide a user-friendly interface to implement machine learning algorithms. Scikit-Learn is known for its ease of use, flexibility, and scalability. Classification, regression, clustering, and dimensionality reduction are the main machine learning tasks that Scikit-Learn supports. Classification is the task of predicting a discrete outcome, such as whether a given image contains a cat or a dog. Regression is the task of predicting a continuous outcome, such as the price of a house based on its characteristics. Clustering is the task of grouping similar data points together based on their similarity, and dimensionality reduction is the task of reducing the number of features in a dataset while preserving as much of the original information as possible. In addition to supporting these machine learning tasks, Scikit-Learn provides a wide range of tools for data preprocessing, model selection, and model evaluation. Data preprocessing involves transforming the raw data into a format that can be used by machine learning algorithms. This includes tasks such as scaling, normalization, and feature engineering. Model selection involves selecting the best machine learning algorithm and hyperparameters for a given task. Scikit-Learn provides tools for cross-validation, grid search, and randomized search to help with this task. Finally, model evaluation involves measuring the performance of a machine learning model on a given dataset. Scikit-Learn provides a variety of metrics and methods for evaluating the performance of a model, such as accuracy, precision, recall, and F1 score. Overall, Scikit-Learn is a versatile and powerful library that provides support for a wide range of machine learning tasks and tools for data preprocessing, model selection, and model evaluation. Its ease of use and flexibility make it a popular choice for both beginners and experienced machine learning practitioners. Conclusion. In conclusion, machine learning and Python are two critical components of modern data science. Machine learning enables data scientists to extract valuable insights from large datasets and make accurate predictions, while Python provides a powerful and flexible environment for data manipulation, visualization, and analysis. Together, machine learning and Python are transforming the way we interact with technology and providing new opportunities for innovation and discovery. Thank you for watching, and we'll see you in the next video.